Welcome, friends. In this video, I'll be talking about number classification, that is, examples that are usually used in intermediate algebra. Understanding the classification of numbers can be a fascinating journey through the landscape of mathematics. Here are 10 examples illustrating how different numbers can be classified into categories such as whole, natural, irrational, fractional, and real numbers, and integers. So let's look at the first example. Number classification. Okay, so let's start for example number 1. So example number 1 says that the number 5. So the number 5, it's a natural number. It's natural, it's a whole. So natural because it's 1 or greater, whole because it's 0 or greater. It's also an integer because it belongs to, is either an integer holds all whole numbers and whole numbers and negative whole numbers. It's also irrational because we can put the following fractions: 5 over 1, and that will consider 5 irrational. And it's also a real because any real and any of these natural whole into irrational belongs to the real, so it's also a real number. Let's look at example number 2. The number 0. It's not a natural, but it is a whole number because 0 is included in the whole number, but not in the natural. It's an integer. As I explained before, it contains all the whole numbers and negative whole numbers. It's also a rational because I can do 0 over 1, and it's also a real because anything that belongs to whole integer rational is also real. Let's look at example number 3. The number -3. -3 is not a whole number and it's not a natural because it's negative. So, but it's a negative integer. So it's an integer. It's a rational because -3 over 1, and it's also a real. Let's look at example number 4. 1/2. It's irrational because it's written as a fraction, and it's also a real number. Let's look at example number 5. Square root of 2. So this has a square root, and the square root cannot be changed to an integer or a whole number. So this one is not something like square root of 4 that you can say is 2. So this one is not like that. So that one is not a rational because you cannot turn it into a fraction. So it's gonna be an irrational. in a real, because it's irrational because you cannot turn it into a rational like that. 2 equal to 2 over 1. Let's look at example 6. Any irrational is also belongs to the real, so it's also real. Then 3 over 4. That's a rational, and it's also a real because it's a fraction. Let's do example 7. The number 0.333. So that's a repeating decimal. So that one belongs to the rational because it's a repeating decimal. And it's also a real because any rational belongs to the real. Let's do example 8. The number pi. Remember, the number pi is approximately 3.1415, and the decimal is infinite. So this one is not a rational because I cannot turn this decimal into a fraction, but it is irrational, and it's also a real. Any irrational is a real. Let's do example 9. -7/2. -7/2 is a fraction, it's a negative fraction. So this one is a rational. It's also real because any rational is a real. Let's do example 10. So it's going to be negative square root of 5. That one cannot be turned into a whole number. So, or it doesn't, the number inside the radical doesn't come out. So this one is going to be an irrational for that reason. And since it's an irrational, it's also a real. I hope you like what you saw. Thank you for watching. Please subscribe.